I'd like to introduce the first speaker, the first presenter of this evening, and that is Chi-Young-Wei Huang from chemistry. And the title of the presentation is Feeling is the Truth, Inhomogeneity in Materials.
What do you see in this color image? I took this photo a few years ago when I visited Shanghai. The display of the thousands of candles is phenomenal. Yes, also sweet. But what really makes the eyeballs attractive is not only about the numbers, but how they pack to each other. You see, they have different sizes, shapes, some of them align in a vertical way, some of them in a horizontal way. All these differences, we call it inhomogeneous properties. In real life, all materials are inhomogeneous. The materials I studied can be used in our everyday electronic gadgets, from cell phone, laptop, to the batteries and solar cells that power our electronics. To study the inhomogeneity in the materials, I need a special tool to look at it. Otherwise, I will see information that's averaged out like the other half of the image. They are distorted, smeared out, and not real. To capture the real inhomogeneity, I use scanning probe microscope. There is a saying, seeing is believing, but feeling is the truth. And that is how scanning probe microscope works. Imagine you slide your finger across the surface of an object. You can feel the texture, shapes, all the information is transferred from your fingertip to your brain. And the concept is analogous to scanning probe microscope. Instead of a fingertip, I use a very sharp tip and bring in closely to the surface of the materials. All the information can be carried through the tip to the computer and get analyzed. The microscope is powerful when the materials at tiny length scales at nanometers. That is 1,000 times thinner than your single strand of hair. Why do we make it so small? Turns out they have a higher and better electronic performance. For example, the graphite in the pencil, we don't normally consider conductive. But when we peel, because electron doesn't want to move, but when we peel it off to a few nanometer thick, it becomes highly conductive. If we can use that material to the cell phone and laptop, it can be running at higher performance. If we use that to the batteries and solar cell, it can be running at a lower power consumption, and so we can save a lot of energies. The level of inhomogeneity can influence how they function in the applications. Just like the inhomogeneity in these candies, the size, shapes, packing structure, all matters. To find out the real inhomogeneity, remember, feeling is the truth. Thank you.
Thank you, Chung-Wei.